Hello, my name is Robert Smith, and I'm with New River Community College. And today we are looking at some simple reactions with organic molecules. And there are several different reactions available to you in your textbook. We're just going to go over a couple. And right now we have this complex organic molecule, and we're just going to focus on a couple things. So let's start with, let's call this reaction, we'll just number the reactions. So this will be number 1, number 2, and number 3. Okay, so with number 1, we're just going to zoom in on this area or this area. So for this one, we have, so let's call this area A and area B. So for area A, we have a carbon that's attached to two things. We're going to say that's R and R prime. And then it's double bonded with a carbon that's attached to, let's call this R double prime, and a hydrogen. And actually B is the same as A, so A and B are equivalent. So that's all you would need to know for the overall structure, what we're focusing on. And that's the trick with dealing with organic chemistry, is you just want to zoom in on the part of the molecule that you are dealing with directly in the reaction, because this might be a very intimidating looking molecule, but really we're just focused on that double bond in our first reaction. So what we would want to do is go ahead and see what would happen if we added chlorine to the to this reaction. Now, if you add chlorine gas, if it's HCl, then it would break the double bond and then add a hydrogen on one side and a chlorine on the other. If you're adding just straight chlorine gas, it'll break this double bond. And you'll have, because carbon wants 4 bonds, it'll add a chlorine to one side and a chlorine to the other. And that's true for site A or site B. Okay. So that's how you would predict how that would look. So the overall structure would have single bonds at site A and B and chlorines coming out of them. So that's reaction 1. For reaction 2, let's start back at the beginning. And what you would do is you would have a hydrogen gas. Hydrogen gas by itself won't do anything. It'll just stay there, won't break any bonds or anything like that. But if you add this platinum catalyst, or it could be a palladium catalyst or any number of other catalysts, you basically change this so that you have hydrogens. You break the double bond, and then on either carbon you add those hydrogens. They've split up and they've bonded with those carbons. So all it would do, if you were redrawing the structure, is it would just look like single bonds, because the hydrogens are implied in the way this wire diagram. The hydrogens are just implied, so it just look like single bonds, much like up here there's single bonds. So that is reactions 1 and 2. Reaction 3 is a little different. It's involving benzoic acid. So that isn't going to involve sites A or B. Benzoic acid is going to react at site C. Okay. And at site C, we have, we can zoom in, where we have a carbon, and that carbon is attached to two things. Let's call this R, and this side is R prime. And yes, it is cyclic, so it's kind of confusing, but really what's going to happen is if you just keep going out, they do change over time. So like if you go 2 sites out from R, it's different than 2 sites out from R prime. So that's why we denote them differently. So this is R and R prime. And it also has a hydrogen that's implied. and an OH group, hydroxide group. And what's going to happen when benzoic acid comes in, when you add benzoic acid, is it's going to deprotonate that oxygen, that hydroxide group, and you're going to end up with this new structure that's going to have the same R and R prime and hydrogen, but instead of hydroxide group, it's going to have this O and then a carbonyl, which is a double bonded to an oxygen, and then a benzyl group. So it's going to look like that instead. So if that's how it would, this part right here replaces this part right here. So that's how that reaction would go through. These are just a couple of reactions that that are very simple, that could be used on a rather complex molecule. But the main purpose of this video is to show you that even if you have a complex molecule, you just want to break it down and focus on the areas where the reactions are going to occur. And once you've identified those, the pattern expands out based on what reactions you know about. So we know that benzoic acid is going to react with that hydroxyl group. We know that chlorine gas and hydrogen gas with platinum will react with those double bonds. So keep that in mind as you go forward. I don't believe that you'll have too many of these to worry about at the general chemistry level, but this will show up again and again and is the main focus of organic chemistry.